Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the derivative of the logarithmic function. So before going to the problem, so we have to know what about the logarithm functions are. So you have two different types of logarithmic function. So one is, let's say, logarithmic log functions. So we will have a common log and natural log. What is the meaning of common log? So here we will have a common log and this is the natural log. So in the common log, what is the difference? So here when you say here log x, it's a common log. When you say it is a ln x, so it is a natural log. So what is the difference between these two? So the same thing, the only change you will have here is to the base. So whenever you will have a common log, it is a base 10. So I can write it this one, the base 10 as log x. So when you have a base e, we say it is a ln. So this is the only difference between the natural and common log. Now we will study some of the properties of the logarithmic. So property of log function. So this is very important to solve the problem. To solve the problem. So number one, the first one we will have. So what is the log of 1? What is the log of 1? Is equal 0. Number 2, the next one we will have log b base b. So answer is 1. Now the next one is a product rule. Log a into b is equal log a plus log b. And the next one we will have log a over b equal log a minus log b. So these properties hold for the both common and natural log. And the last one we will have a power rule. So if you have a log a to the power m, I can bring this power here. So this is a power. So this is a power rule. So m times of log a. So this is the 5 important properties we are using to solve or simplify the logarithmic function. So let us check how to solve the problem. And what is the derivative? What is the derivative of the log function? So here we are using this part. Here we are using, yeah, take. So the derivative of the function. So y and dy over. So when you have a ln x, so the derivative is 1 over x. When you have a log x base b, so it is the same thing 1 over x, but it is ln b. So it is a base b. Whatever be the base you have, this one is your value. Now we will use this rule to solve the problem. To solve the problem, we will make use of this formula. Yes. Now let us solve the first problem. Here, what is the derivative of differentiate the y equal ln x plus log x base 2. So here the y prime is equal y prime. Here, what is the derivative of ln x? It is 1 over x plus it is a log x base 2. So it is a base 2 means you have to use this formula. 1 over x and then we will have ln 2. So this is the direct rule. So I write it here. 1 over x plus 1 over x ln 2. So this is the final answer. So now on number 2, y equal x into ln x. So it is in the product, so I have to use f into g, that is the product rule. So here it is product rule. So what is the product rule we have? So y prime equal f g plus f g. So f prime g prime. Now what happened here? So y prime is equal, what is f differentiation, which is equal 1. And this ln x will be the same, plus f is fixed. What is the differentiation of ln x? It is 1 over x. 1 over x. Now what is here? Cancel. You can simplify. And the final answer will be y prime is equal ln x plus 1. Ln x plus 1. Now the second one, the third, we will have the function f over g. So whenever if it is over, it's a quotient rule. It's a quotient rule. So in the last one, it is in the product. So whereas here, it is in the quotient. So I will use the quotient rule. What is the quotient rule? So the y prime is equal g fixed g square g fixed f prime minus f fixed g prime. So if I substitute the value, what happened? Y prime is equal whole over ln x whole square. Then here ln x will be fixed and differentiation of x is 1 minus x is fixed. What is the derivative of the ln x? 1 over x. Now what is cancel here? So here x with the cancel here. You can simplify and the final answer will be ln x minus 1 over ln x whole square. So and by the way, you cannot cancel this one because of minus 1. If it is not minus 1 is there, you can cancel this part. You can further simplify. So this is a quotient rule and this is the product rule we have taken. Now let us go with the next problem. How will you solve the next problem? So it's a y equal ln of x square plus 4x plus 5. Therefore, it's a chain rule. So first you have to differentiate the ln. The number 2 you have to differentiate the inside function. It's a composition function. So I will use the chain rule here. So what is the first thing? Y prime is equal. If you differentiate a ln, it becomes 1 over x square plus 4x plus 5. So ln is over. The differentiation of ln is over. Now I have to differentiate the inside the term. So what is the inside term? So it's a 2x plus 4 and 5 becomes 0 since it is a constant. Since it's a constant, therefore it becomes 0. Now the simplified answer will be y prime is equal y prime is equal 2x plus 4 over x square plus 4x plus 5. So here we cannot apply the product rule because there is no x. It is a function of function. Suppose if you will get like this, x into this one, then you can use the product rule because there is a 2x. But it is not the case here. You will have a function of function. That's why you cannot use the product rule. Chain rule you have to use. Now similarly, we will have the next one. We have 1 is a length, the function of function and the inside 2. When you do the inside, it is a product rule if you apply the chain rule. Otherwise, I can use this one as a property. Using property, it becomes very simple. So there is two methods to solve here. Either you can apply the chain rule by using this one or I can use the property. I will use the property to solve the problem. So what is the property of log? So here you will have y equal ln x square. Since it is in the product, therefore I will write it plus and then ln e power minus 2x. And then I apply the property of len, so I have to bring the power here. I have to bring the power here. So if you bring this power here, so what happened? This becomes 2 len x minus plus into minus minus 2x len e. So you can further simplify this part since the len e is nothing but what? Len e is base e, therefore e base e is 1. So the final value is equals to len x minus 2x. So this is a simplified form using the property. We are not differentiating here so far. So thereafter we have to differentiate y prime equal 1 over x minus 2. So this for 2 over x minus 2 is the final answer. So if you use the property, it will be very simple. And by the way, you cannot apply the property here because in between you don't have product. It's a plus. If you have a product and the log is a common function, you can apply the property, right? So there is another method you will have here. If you solve by chain rule, after simplifying all the answer, you will get the same pot. So whenever you will have this type of problems, apply the property, the function become very simple and then you can differentiate easily. So this is what you have. So up to this part, we are applying only the property. Here the differentiation starts. Now the next rule. So f of t equal len t whole square and then sine t. So how will you solve this one? So I write it this part as len t. This is whole square. We cannot apply this rule. So this is fg. So I have to use fg. So what is the rule? Fg f prime g prime. And then we will have, so this f prime of t is equal, what is the differentiation of f? So first you have to do the power. So if you do the power, 2 times of len t power 1. If you differentiate inside, 1 over t. So this is the f prime. So this is the f prime. Now g will be fixed. G is what? Sine t plus. Now this one is fixed. Len t whole square is fixed. What is the derivative of sine? Which is equal cosine. So it is cosine. Now if you simplify, so y f prime of t is equal to len t over t into sine t. You can write it in the numerator as well, plus len t whole square cosine t. So that's it. So this is the answer. So you have to use the product rule since it is in the product. Now let us go to the next one. So here it is a chain rule. Why? Because a function of function. So I will use this one as the first and this one is a second. Let us check. So it's a chain rule. Y prime is equal. First, if I differentiate a ln, 1 over cosine x minus cotan x into, what is this part? Cosine differentiation minus cosec cotan. And here you will have, what is the differentiation of the cotan? It is minus of minus plus cosec square x. Cosec square x. And then we will have a y prime. So I am taking a common factor. What is the common factor here? You will have cosec, cosec. So I will take that one as a common. So if I take this one as a common factor, cosec x, so what is the remaining? I write it the first plus term. So you will get square remaining one term minus, we have taken cosec x outside, remaining is cotan x over cosec x minus cotan x. Now here cancel, minus with the minus cancel. What is this one here? Y prime is equal cosec x. That's it. So this is a simplification is compulsory you have to do using the common factor. Now the next one is the tangent line. So it's a tangent line. So what is here? You have the function and also the points are given. So what are the points? The points are 1 comma 6, 1 comma 0. So this is x1 y1. We need to find the m is nothing but the slope. So how will you calculate the slope? Slope is nothing but y prime. So here the given function is y x square ln x. So I want to calculate the y prime. Y prime is equal, this is f into g again. So this is fg. So what is the rule? fg fg prime. Yes. So if you do this one, so it is 2x ln x plus, then we will have x square 1 over x. So what is cancel? This with this cancel. Now if I substitute x equal 1, so what happened? Y prime is equal 2 times of 1 ln 1 plus 1. So since ln 1 value is 0, the whole term becomes 0. Now the value will be here y prime, that is m is equal y prime, which is equal 1. So I got it the m value. I got it the m value. Now equation of a tangent line. Equation of tangent line. Y minus y1 m times of x minus m x1. Y is 0, m is 1, x minus 1. So if I write it x minus 1 and it is equal y. So this is the equation of a tangent line. Now this is a very important part of the logarithmic function. Whenever you will have a complicated functions, we will take a length. So this is a complicated function. If you do it this one, you have to do the f over g. When you do the f, again it is a product rule. When you do the g, again it's a product rule. So it is a complicated function. So difficult function, big function. So whenever you will have like this term, I will use len both side. Take len both side. This technique we will apply. Take len both side. If you take len both side, you will get what? Len y. Here you will get len of e to the power minus x into cosine x whole square. This is whole square over sine x into x square plus x plus 1. As per the property we know, the logarithmic property, when it is a product, I have to write it as a plus. I have to write it as a plus as per this rule. So if it is product, I write it plus. If it is over, I write it minus. So same rule I am applying here. So what is this here? Len y equal. So if I separate the first term, you will have a len e power minus x. Since it is in the product, so it is plus len cosine x whole square. When you go with the name divide, all the term will be minus. So it is minus len sine x. Is it right? Because sine is in the denominator. And then you will have a minus len x square plus x plus 1, because this term is also in the denominator. So you will write it a minus. Now after that we will use the property of len again. So what is this? I have to bring this power. So I will bring this power here. So power rule. So I use the power rule. So what is the power here? So it is minus x len e plus 2 times of len cosine x, and then minus len sine x and minus len x square plus x plus 1. Now I just do it this one. So what is this part? We know this one is equal 1. So how it is 1? It is log e base e, which is equal 1. So I got it this value, the final simplified 1. So here minus x plus 2 times of len cosine x, and then minus len sine x minus len x square plus x plus 1. So far in these four steps, you can cut short the step if you understand. Since it is the first problem, I write it elaborately. So here, so far, we are not making any differentiation. Just we are applying the log and applying the property of len. Now we will differentiate here. So it is a chain rule. Therefore, it is a 1 over y. Len y is 1 over y. Y differentiate y prime implicit. Now here you will have what is the derivative minus 1 plus 2 is a constant like a c differentiation of this part. So what is the differentiation of this one? 1 over cosine. How the len over. What is the differentiation of cosine? Which is minus sine. So that's it. Now let us go with the next part. Minus again here chain rule. So what is the chain rule here? What is the chain rule? So first if I differentiate 1 over sine x, sine differentiation cosine x. The next one, go to the next here 1 over x square plus x plus 1. When you differentiate inside, it becomes 2x plus 1. Now I write it this one as 1y into, so this is equal minus 1, so it minus here minus 2, what is sine over cosine, which is tan, minus cosine over sine, which is cotan, and this cannot be simplified as it is. So 2x plus 1 over x square plus x plus 1. So this is the entire part you have, and in the left side you will have y. I don't want this part, I will move it this one to the other side. If I move it this one, this division, it becomes multiplication. When you multiply, it becomes multiply by y, or both side multiply y get cancelled. On the left side you will have a y here. Now what is this y? So I have to give the answer in terms of the x. So I replace the question. What is this one? So this is nothing but the same thing which is given in the question. What is this one? E power minus x. This is the same thing we will have. Copy here and then we will paste it here. So this is the same y prime, y. So y prime is equal, y prime is equal. So this is 1 minus 2 tan x minus cotan x minus 2x plus 1 over x square plus x plus 1. So this is the two things. So this is a very important rule for the logarithmic, and the benefit of the logarithmic differentiation. When you have a complicated function, we will take len both sides. And this is the one situation where we can take the log. And there is a one more situation we will have. What is that one? So whenever you will have the x in the power, see the power is in the x. So also here also we will take the len both side. So in these two situations we will take len both side. So here also I am taking len both side. Take len both side. Both side. So this is len y is equal. If you take the len, the sign will becomes here and here len x. Now differentiate easily. 1 over y prime. So here you will have what? So this is a product rule. It's a product rule f. This is g. So what is the derivative here? So f g f prime g and f g prime. So you will get here the first one cosine x len x fixed plus sine x 1 over x. Now when I multiply this one here, multiply y. So here what things are simplified, there is no just multiply, and here it is 1 sine x over x. And what is the next step? I have to replace the y. Y is equals the given question, that is x to the power sine x. And this is the final answer. Y prime equal this part into cosine x ln x plus sin x over x. So this is a very important uh, application of the len to solve the complicated function and the x in the power. Thank you.